What new battery technologies are on the horizon? Welcome to the DIY Off-Grid channel where we talk all things off-grid, and today we're going to talk about some of the new battery chemistries that are around the corner and what to keep an eye out on. Batteries are quintessential for off-gridders. There's simply no way around it if you want to run your electrical devices around the clock, storing every precious watt-hour generated by your renewable energy systems. Yesterday, we covered all the incumbent battery chemistries for both on and off-grid energy storage. We're going to look at what the future holds for battery technologies, specifically covering sodium-ion batteries and solid-state batteries, and how they compare with what we have today. So without further ado, let's dig right in. Sodium-ion batteries is first up, and it's definitely a battery technology we discuss quite often during our live streams. It's commercially available today, it's being produced in large quantities, and it has potential. At the moment, it isn't quite price competitive with the leading lithium chemistries, and in terms of performance, the energy density in both volume and weight is still some ways behind compared to LFP and lithium NCX batteries. If you recall, NCX batteries are almost at 300 watt-hours per kilogram and exceeding 800 watt-hours per liter, while LFP batteries are at about 150 to 180 watt-hours per kilogram and 320 to 380 watt-hours per liter. Leading sodium-ion batteries are about 20 to 40% lower than LFP batteries at roughly 120 to 150 watt-hours per kilogram and 240 to 300 watt-hours per liter. For non-motive applications such as stationary home energy storage use, these aren't particularly bad figures. They just don't provide any real benefits quite yet. Now, I've tested a handful of cells from various different manufacturers, and at the moment cycle life is also roughly about half that of LFP batteries, though that's already a bit better than NCX variants. Another advantage it has is cold temperature operation. It is capable of operating around 10 degrees Celsius colder than LFP batteries across the various cells we've tested, which for our friends living in northern latitudes or higher elevation, it would be a big welcome. Now, based on our tests, the safety of sodium-ion batteries there's a slight improvement compared to LFP batteries, and it's a bigger improvement over NCX cells, but that seems to correlate well with the energy density of the batteries, so there really isn't a guarantee it will be much better if the density improves from advancements in the actual technology, at least from what we can deduce today. Now, one big challenge, however, is the operating voltage range of the current sodium-ion batteries. If you watched our segment on LFP batteries yesterday, a 4-cell LFP battery has almost identical operating voltage parameters compared to a 6-cell lead-acid battery. The real challenge for sodium-ion batteries is the fact that it takes a full charge at nearly 4 volts per cell, and the low voltage cutoff is as low as 1.5 volts. Now, why is that a problem? Let's assume a 1000 watt load on a 12 volt lead acid or LFP battery. At 14.6 volts max charge voltage, 1000 watts is around 68.5 amps. At the low voltage cutoff of around 11 volts, the same 1000 watts draw 91 amps. The issue with sodium ion cells, however, with the 4-cell battery, the maximum voltage is 16 volts and the cutoff voltage for low voltage is just 6 volts. At 16 volts, 1000 watts is 62.5 amps, but at 6 volts, it's 167 amps. Inverters and charge controllers will have to be completely reworked to accommodate its wide operating voltage range, as current ones designed for lead-acid or LFP batteries simply won't function with these cells. Now, sodium is indeed a substantially more common element than lithium is, but if we consider the fact raw lithium hydroxide or lithium carbonate only makes up about a quarter of the cost of a lithium battery today, it'll be interesting to see if they can really bring down the cost to a price point where it will fulfill a niche separate from lithium-based batteries. Now, it's certainly possible, but if we look at the history of novel battery technologies that were promised in the past 2 decades, almost all of them failed because they couldn't take into account how much effort was put into lithium batteries to bring their costs down. Theoretically, sodium-ion batteries can be around 30 to 40% cheaper than leading lithium batteries today, but do keep in mind, lithium battery pricing has been a moving target that's gone down tremendously over the years. Next up is solid-state batteries, which is a really broad topic altogether. Solid-state batteries cover any and all chemistries that involve a solid electrolyte versus liquid or gooey gel-like polymers used in conventional batteries. As of now, the vast majority of the focus is on existing lithium chemistries, and they are on track for incremental improvements in both volumetric and gravimetric energy density. Though there are a number of research papers and press releases put out with some wild claims, feels like there's something new every week. The reality is, there will be much more nuanced, as the elephant in the room is just the sheer scale of current NCX and LFP battery production manufacturing capacity. I've reached out to some of these battery companies working on these lithium-based solid-state cells. The costs are expected to be about 3 to 6 times higher per watt hour compared to current conventional lithium battery chemistries, and even then the consensus is it's still a few years out at the earliest. The potential advantage is improvements in safety, faster charging, more cycle life, and better cold operating temperatures than current lithium batteries, similar to how we brought up LTO or lithium titanium oxide batteries in the conversation yesterday. But with the one major difference being higher energy density. Some of the solid-state batteries closest to commercialization are expected to reach or possibly exceed 1,000 watt-hours per liter and 400 watt-hours per kilogram. Definitely an improvement over the best lithium batteries today, but nothing too earth-shattering in that regards. Now, how will solid-state batteries impact energy storage application for use in on and off-grid homes? My guess is it really won't. Energy density, it's not really an issue for home energy storage today. The improvements will make the most difference in the automotive industry, especially in high-performance vehicles. And to be frank, my bet is that's where the first solid-state batteries will go. I'd imagine a company like Samsung SDI working with Porsche or the more exotic brands to be the first to adopt the technology. Unlike sodium-ion batteries, where it's a bit clearer to see potential cost competitiveness, the current yield rate and the cost of manufacturing solid-state variants right now don't really give way to making any inroads for energy storage applications. My thoughts on the future of energy storage: I think LFP batteries will be the go-to choice for the next decade. The economics already make sense at 2024 prices, while the cell performance and prices will incrementally improve in the long run. Sodium-ion batteries have the potential to make inroads to the energy storage market, but it has to come down to a lower price tag to be competitive. It hasn't happened yet, and from my experience visiting the factories producing them last year, their production is being subsidized to get it closer to parity with LFP batteries. But without the industry support from the inverters, charge controllers, battery management systems to handle that wide voltage swings and the wiring to support the wide current swings, it too has an uphill battle. If you're thinking of going solar with an energy storage system, do fill out our DIY battery sign-up sheet at my website, allthingsoffgrid.com. It's a free one-to-one consultation to walk you through the whole process of setting up a renewable energy system for your home. I will walk you through every step of the process to design and spec a system that is not only cost-effective, but long-lasting and designed to meet your energy needs. Thanks for tuning in to the DIY Off-Grid channel today. Don't forget to tap that like button and subscribe for more insights and tips on living off-grid and sustainable living in general. Got questions or topics you'd like me to cover? Drop me a line or leave a comment. Until next time, guys, stay safe, stay healthy, and stay curious.